Hey everybody, today we're going to do 5-1. We're starting chapter 5. 5-1, 5-2, and 5-4 are all kind of the same. 5-2 is a system of linear equations in 2 variables. 5-2 will be in 3 variables. And then 5-4 will get into like having squares and stuff like that and solving systems of equations. Chapter 5 is definitely the best. People like it the best. It's just not bad at all. There's only 5 sections in it. The first 3, like I said, are solving systems. And then the last 2 are graphing inequalities, basically. There's some other stuff thrown in there too, but it kind of follows a nice theme. It's not bad to do. So hopefully you like it as your last section in college algebra. Alright, so checkpoint 1, you're basically determining if an ordered pair is the solution. Okay, so for this one, we're given the system of equations 2x minus 3y equals negative 4 and 2x plus y equals 4. And then we have to determine if the ordered pair is a solution. For part A, we're given the ordered pair 1, 2. So if this is a solution, what's happening is you have 2 lines. And more than likely, the most common thing that's going to happen is if you're to graph the 2 lines, they intersect at one place. Okay, so we want to find out if that's in the intersection. That's not the only way this could happen. They could also lie right on top of each other. We'll get to that case in a little bit, but we're just going to see if this is a solution by using algebra. So first, I'm going to plug into equation 1. We have the 2x minus 3y is negative 4. And we're going to plug it in. We're going to plug 1 in for x and plug 2 in for y. So we're going to basically see if this point lies on this line, just period. Does it lie on there? So 2 times 1 minus 3 times 2, does that equal negative 4? 2 minus 6 equals negative 4. Yep, it sure does. So that point lies on that line. Then we need to see if it lies on, if it didn't, we would be done. There's no way. So now I'm going to see if it lies on the other line. We have 2x plus y equals 4. So 2 times 1 plus 2 equals 4. 2 plus 2 equals 4. Yep, sure does. So this point is a solution. So yes, 1, 2 is a solution. Basically what we're doing here is just learning to check our answer. Any answer you ever find, like we're going to be solving these, we're not going to just do this, but any solution you ever find has to work in both, not just one or the other. So that's always a good check, even if you can just do it in your head real quick. Alright, so our next point is 7, 6. So let's see if it's in both equations. So 2 times 7 minus 3 times 6, because 7's our x, 6 is our y, equals negative 4. 2 times 7 is 14, minus 18, and that does equal negative 4. So we go on. If it didn't, we would stop. Our second equation, 2x plus y equals 4. So we have 2 times 7 plus 6, does it equal 4? 14 plus 6, does it equal 4? Nope, it sure doesn't. So this is not a solution. It lies on one of the lines, but not the other. So 7, 6 is not a solution. Alright, so now let's actually get into solving these. We're going to solve by the substitution method first. So checkpoint 2 is to solve by substitution. And some people really just don't like solving by substitution. You can get away with it with these, but when it comes to doing 3 equations, 3 unknowns, you're going to have to know how to do your substitution. So you might as well get a hang of it now. But most people like the addition method. Alright, so this one, to solve by substitution, we've got our equations 3x plus 2y equals 4 and 2x plus y equals 1. Okay. Alright, so we're going to have to figure out which equation we want to plug into the other one. If you look at your coefficients, you have 3 and 2 and then 2 and 1. You want to pick the one that has a 1. So I'm going to take this equation and solve it for y. That would be y equals 1 minus 2x. Okay, so the first step is to solve an equation for one variable. Alright, did it. Second step is to substitute that equation into the other one. Don't plug it back into itself, that'll get you nowhere. To substitute the equation into the other one. Alright, so our other equation, we have 3x plus 2y equals 4. So we know this, we know y is 1 minus 2x. So we're going to substitute that in for y. So 3x plus 2 times 1 minus 2x equals 4. We just eliminated the y's. Now we only have x's. So step 3 is to solve the equation that only has one variable. So solve the new equation that only has one variable. Alright, so I'm going to distribute that 2. So we have 3x plus, this will be 2 minus 4x equals 4. 3x minus 4x, that's negative x plus 2 equals 4. Subtract the 2, negative x equals 2. So x equals negative 2. Alright, now I got a variable for a value for one variable. Now I'm going to take that and plug that in to find the unknown. So now we're going to plug in the unknown variable, and actually it doesn't matter where. We're going to plug in the known variable to find the unknown. So to find y in this case. Okay, and we actually know from above that y equals 1 minus 2x. So I'm going to use that. And I'm going to plug that in for x. So y equals 1 minus 2 times negative 2. So y is 1 plus 4, which is 5. So now we have x equals negative 2, and we have x equals 5. And you could check this the way that we had the others. They're done in checkpoint 1. I'm not going to, but the answer, write it as a coordinate point, is negative 2, 5. And that's solving by substitution. Okay, checkpoint 3 is to solve by elimination or addition method. Different books call it different things. Checkpoint 3. Just use their words, solve by addition. Alright, for checkpoint 3, we are given 4x plus 5y equals 3, and 2x minus 3y equals 7. So the first thing you want to do is make sure they're in ax plus by equals c form, which this one they are, so we're good to go. But that would be step 1, would be to rewrite equations in ax plus by equals c form, which is the more typical standard form that you would see in other books. Okay, we're good. We don't have to do that. Step 2 is, this is the main step. You're going to pick a variable to eliminate. So, like, I look at my x's, I have a 4 and a 2. I look at my y's, I have a 5 and negative 3. I want to have the same variable in the front with opposite signs. So the perk to the y's here is that you have a 5 and a negative 3, a positive negative. So you could make them into 15 by multiplying this equation by 3, this equation by 5. You would have a 15 and a negative 5. Or, get rid of your x's, you have a 2 and a 4. They could both be 4. You just need to multiply this second equation by, actually by negative 2. 2 times negative 2 would be 4. And then the 4's could cancel out. So it doesn't matter. So for step 2, you pick a variable to get rid of, to eliminate. That's why sometimes it's called elimination. Okay, and then multiply each equation by a number. It could be 1. So multiply each equation by a number. So one variable has the same coefficient with the opposite signs. Okay. So we'll take our 2 equations. I'm going to go ahead and get rid of the y's. I don't like dealing with negatives because I feel like there's too much room for error. So I'm going to multiply this first equation by 3 and multiply this second equation by 5. So I have the 15s. Alright, so we'll have 12x plus 15y equals 9. And then 10x minus 15y equals 35. All right, and then step 3, we're going to add the equations together. This will eliminate a variable. So our y's will cancel because we have 15 and negative 15. 12 plus 10 is 22x equals 44. And then you're going to solve your new equation. So just divide both sides by 22, and you end up with x equals 2. Okay, there's half of our answer. Now we're going to plug in the known variable to get the unknown variable. Right, and it doesn't matter where you plug it in, so you can just kind of pick one. I'm going to pick the one that has a positive y. So I'm going to choose 4x plus 5y equals 3, and plug our x2 in for x. So we have 4 times 2 plus 5y equals 3. So 8 plus 5y equals 3. Subtract the 8, so 5y is negative 5, and y equals negative 1. And there's your answer. Right, and that's solving by addition. All right. Checkpoint 4 is also to solve by addition, but the answer is just a little bit more complicated. All right, let's see, we have 2x equals 9 plus 3y, and then we have 4y equals 8 minus 3x. All right, so this one is not in like the standard form. So this one we need to move stuff around. We need to move the 3y after the 2x, and then I'm going to move the 3x in front of the 4y. So we'd have 2x minus 3y is 9, and 3x plus 4y equals 8. All right, and I'm going to do the same thing I did in the last problem. The y's have a negative 3 and a positive 4, so I'm going to make them both into a 12. I'm going to multiply the first equation by 4, and the second equation by 3. So you get 8x minus 12y equals 36. And then 3 times 3 is 9x. 3 times 4 is 12y equals 3 times 8, which is 24. So when we add together, our 12y's will go away. 8 plus 9, that's 17x equals 60. Divide by 17, so x is really ugly. It's 60 over 17. So here's the thing with this problem is when I used to do this one, I used to plug it in and find my y. And there was a student who was like, why not just get rid of the other variable? I was like, oh, genius. So I go back to the 2x minus 3y equals 9, and the 3x plus 4y equals 8. And instead of getting rid of the y's, I'm just going to plan to get rid of the x's. So I have a 2 and a 3. They can both go into 6. One of them is going to have to be negative. So I'm going to multiply this equation by 3, this equation by negative 2. So we'll have 6x minus 9y equals 27. From the second equation, we have negative 6x minus 8y equals negative 16. So our x's will cancel. Negative 9 and negative 8 is negative 17y equals 11. And then we're going to divide both sides by negative 17. So y equals 11 over negative 17. So there's our two pieces to our final answer, our ugly answer. So our answer is 60 over 17 and negative 11 over 17. Okay. So these have all worked out nicely. Well, I mean, it's kind of ugly, but we still get a nice answer. Checkpoint 5 and checkpoint 6 are the two special cases. Alright, so checkpoint 5 is a system with no solutions, I believe. Yeah. Okay, so a system with no solutions would be if you were to graph the two lines and they end up being parallel. They'll never cross, so they never have a solution. When you start out with these problems, though, you don't always know that they're parallel. You might, depending on how they're presented to you. But for this checkpoint, we're given 5x minus 2y equals 4 and negative 10x plus 4y equals 7. And we're just told to solve it. So immediately I think elimination, because you could multiply that first equation by 2. And just looking at the x's, you would have a negative 10 and a positive 10. But what's going to happen when you distribute that 2, you also are going to get rid of your y's. But what's important is what happens after that, whether you have a true statement or a false statement. So let's see. When I add these two together, the x's eliminate, the y's eliminate. So this side's 0, but the other side is 15. And that's what's important. Like, are those two equal? Are they not equal? 0 does not equal 15. So there's no solution. That's what tells you the lines are parallel. If they were the same, if we got the same thing, like 0 equals 0, then it's infinitely many solutions, and that's what we're dealing with in checkpoint 6. When you have infinitely many solutions, the lines are actually the same. Okay, so for checkpoint 6, we have x equals 4y minus 8. And 5x minus 20y equaling negative 40. Okay, so infinitely many solutions, if you were to graph them, if we graph one of these lines and then graph the other one, you would see that they're actually the exact same line. They lay right on top of each other. So it's not all real numbers because it's not everything. It's only things that work on this line. So let's see here. We have a perfect candidate for substitution. We know that this is equivalent to x. So instead of writing x here in the second equation, I'm going to write 4y minus 8. And then minus 20y equals negative 40. Distribute the 5, so 20y minus 40 minus 20y is negative 40. So the y's will cancel, but now what we're left with is negative 40 equals negative 40, which is true. Right? Negative 40 will always equal negative 40. So that tells us they're the same line. The tricky part to this is the way you write the answer. And different textbooks do handle this differently. But this one does the squiggly brackets and says all x's and y's where, and then you just pick an equation. Like x equals 4y minus 8 is fine. It doesn't matter. So, or all x's and y's where, and then you pick the other equation. You could even pick like a simplified version of these. It doesn't even have to be these. You could have all x's and y's where, let's say we had moved the negative or the 4 over. So 5, oops, just kidding. Or actually just divide this one by 5. So x minus 4y equals negative 8. Okay, any of those are fine answers. It's just saying it's all points on that line. Alright, so that's infinitely many solutions. One more thing that we're going to do in this, and that's the break-even point. And that's checkpoint 7. Alright, so our break-even point. We have a company that manufactures running shoes and has a fixed cost of $300,000. An additional cost of $30 to produce each pair of shoes. So $30 per pair. They are sold at $80 per pair. Okay. For A, it says to write the cost function. B, it says to write the revenue function. And C, it says to determine the break-even point. Oh, not a P. Okay, your break-even point is going to be when your cost equals your revenue. How much you're bringing in equals how much is going out. So our cost, we have a fixed cost, we'll call it C of X. We have a fixed cost of $300,000. And then add on to that the cost per shoe. I'll do 30x because it's times however many shoes you make. The revenue then, how much you're bringing in, that's your R of X, would be $80 per pair of shoes. Alright, so determine our break-even point. That's when our cost is equivalent to our revenue. So that's when $300,000 plus our 30x equals our 80x. So I'm going to solve this, just like solving an equation. 300,000 equals 50x. Divide by 50, and you get 6,000. So that's where the company breaks even, when they make and sell 6,000 pairs of shoes. If they wanted to make a profit, they would need to make more than 6,000. But they don't want to make too many because then they don't have a profit. They'll start losing money because they can't sell them. Okay, so the company breaks even when they make and sell 6,000 pairs of shoes. Alright, and that's that. Alright, that's 5.2. Or just kidding, it's 5.1. I'll be doing 5.2 soon. 5.2 is just 3 by 3s. So 3 equations, 3 unknowns. So it kind of follows the same theme. Have a great day. Be safe.